over the years, man has relied heavily upon the use of fire.
For many things, such as warmth.
Or cooking your food. Gotta cook your food nice and right.
And then you have those times where you need for protection against these guys.
However, there's those times when violence cannot be avoided, and you get war.
Through the years, man has developed new ways of using fire.
Their knowledge has increased greatly.
Oh, what are you guys, stupid or something? What's the problem? What? Give me this thing.
Fireworks are a great example of how fire is used today.
Ah, yes! Yes! Yes!
Quest for fire.
Man has never stopped.
And that's what I'm talking about here.
These are the three things fire needs to be: fuel, heat, and oxygen.
One of the key points to having a fire.
Now, we went around to 3rd and 4th grade classes to ask them what they knew.
That's true. I mean, they could have that, but they
And?
also have other things. But as she said too,
Seems as though they have much to learn, just like the cavemen.
We're going to talk to you a little bit about fire today. To start out with, can anybody tell me what they think fire is?
That would be very, very bad.
Here's a demonstration of what happens when you take away one of the elements of fire.
The candle is burning. If I took and I put
When
this
she places the glass over the candle, she's taking away the oxygen, which will put the fire out.
Wait.
Wait.
White. Oh no, white is.
Yeah,
White's on.
I was about to say that. It's purple.
Do you have a question?
It's outside the box.
And here's the main event.
Yes, we're ready. Okay, well, welcome to the chemistry team's show Quest for Fire. These experiments are things you have the same materials at home. Do you think it would be safe for you guys to try some of these things at home? Okay, so promise me now.
You die if
You're
you're
not
not
going to try any of these at home. Right? About this quest for fire, these experiments that you see are going to challenge your views of what fire is and what fire can do. Remember, this is not magic, it's chemistry. So they can explain what goes on behind the things that look like magic to you.
And we got some magnesium shavings, and this black thing is a char cloth.
Flint and steel.
Right here. What we're about to do is start a fire old-fashioned way with steel and rock.
This demonstrates the burning as a fast oxidation process, unlike a slow oxidation process such as rust.
It's a nice try, but it's not
We're going
lit.
to have them try over off to the side here, and then we'll move on
Not
to the
yet,
next one.
but eventually.
Bench.
Ready, fire?
All right.
Yep, they got
Well,
fire.
we have an experiment, a demonstration that involves a substance called lycopodium.
Lycopodium
is simply
flamethrower.
club moss spores. Hi. By itself, lycopodium is a flammable substance. But it needs enough surface area to light.
As you said, the surface area is the real issue here, and
In
With
3,
enough of it.
2, 1.
you get flamage.
All right, everybody, how's it going? What I've got here is dry ice. Okay, if you notice, this dry ice is so cold it doesn't melt, it sublimes, which means it goes from a solid straight to water.
This is burning in carbon dioxide, which is answering our question: do all fires
I put
require
this chunk in
oxygen
this
to
water right
burn?
here. Can you see this on the? You can't see this, can you? Is it good? Can you see it? Okay. Watch what it does. It'll carbonize the water, which is, you know that fizzy stuff in your pop? That's what it'll do to the water. It'll make it all fizzy like some magnesium chips into a little hole right here. Crevice, whatever you want to call it. Alright. I'm going to light these
Those
magnesium
magnesium
chips
chips
and
are
you'll see what
placed in
happens from there.
They will be ignited. Once ignited, another block of dry ice will be placed over the top of them, showing that the flame is burning much brighter.
Pretty cold stuff.
Right here it's called ether. It is very flammable.
This is the
And-
ether trough demonstration.
Yes. I'm going to put 20 milliliters of ether through these cotton balls that are inside of this strainer, and a vapor will travel down this trough, and when it hits the flame, you'll see something.
Not sure if you can see
Well,
this.
you can see that
There's no.
when the ether is poured down, it's not actually running down the trough, but it's the gas. The gas is what lights the fire.
Interesting.
It didn't work there, but you know, it'll work in the next one.
Wait,
It's being a little slow.
fires don't need solid fuels, do they?
No, that's why we
shown
have
here.
cotton balls.
Cotton work.
And with a little chemistry, you get that.
Something amazing.
Not so much there, but you know.
Our experiment that we're going to show you involves methanol. Methanol
bottle.
is a flammable liquid, and the actual experiment we're going to show you actually is not, it doesn't use the liquid itself, it uses the vapor, which is the gas that comes off the liquid. But before we do that, we're going to show you what happens when you light just the liquid methanol. He's going to light that and show you what happens.
So showing you this, I'm going to tell you. They will use a 5-gallon jug that is capped and swirl around the vaporized liquid. The cap is then removed,
Okay, do you guys see
and
that?
the excess methanol is poured off. And as you can see here, a flame source is introduced into the bottle.
Huge bottle.
Compound called calcium carbide into a bowl. Now, what we're going to do, you will soon see, but we're going to form a reaction that forms acetylene gas.
All right.
Fire
here's
and ice.
Fire and ice. Yes, yes. Now, when the calcium carbide and the melting ice react, it's going to form settling gas, which burns and you get a flame. A real world application of this is underwater flares.
This here is underwater fire.
Don't need it to burn in air, just need.
We're going to generate some chlorine gas with the reaction of hydrochloric acid, a strong acid, and potassium permanganate, a strong oxidizing agent.
Hydrochloric acid and freshly crushed potassium permanganate react to form chlorine gas. The gas is bubbled into a 12-graduated cylinder of water, and calcium carbide is tossed into the cylinder, which reacts with the water to form settling gas. When this happens, flashes of light appear underwater.
It's not magic, it's chemistry.